we are required to draw the next diagram in the sequence. With the length of each side increasing by 1 unit each time, the next shape will have 4 units on each side. So there we have it, 1, 2, 3, 4 units on that side, and of course 1, 2, 3, 4 units on the other side. The entire question 8 was not available. I have therefore made use of bits and pieces of information in order to make a guess what another part of the problem could have been. By observation, it may be concluded that the numbers in column 2 represent the perimeters and those in column 3 represent the areas. So when n is equal to 4, perimeter is equal to 4 times 4, which is equal to 16, and of course the area is going to be equal to 16 also. When n is equal to 7, the perimeter is what? 4 multiplied by 7, because it has what? 4 equal sides of 7 units each. So that's going to be 28 units. And of course, the area is going to be the length multiplied by the width. In this particular case, we have a square. The length and the width are equal, and they are equal to 7 units. So the area is going to be 7 multiplied by 7, which is equal to 49. General representations for entries in columns 2 and 3 are 4n and n squared, respectively. We have here a system of simultaneous equations in which one is a linear and the other is quadratic. The system may be solved in many ways. This time we will use the process of elimination. Subtract equation 1 from equation 2. By so doing, the y's will be eliminated from the left hand side, and all we will have is, of course, if we subtract 1 from 2, we'll say x squared minus x. Of course, we will be also subtracting 2. So it will be everything that we have on this side minus what we have right there. So x squared, we are going to subtract x, and we are going to subtract 2. So we have x squared minus x minus 2. We have a trinomial, and the equation may be solved by factorization. So we have this quadratic equation, and we are going to solve that by factorization. Of course, we are always accustomed to having the terms, the non-zero terms, on the left hand side and 0 on the right hand side. There is no harm in having it the other way around, and solving the equation in this manner will yield the exact same result anyway. So let us go straight ahead and factorize. Of course, we are going to say what two numbers multiply to give negative 2, and when we add them we get negative 1. Of course, those two numbers are negative 2 and positive 1. So we will have x plus 1 and x minus 2, or the other way around. Let's see which one we will have. We have x minus 2, x plus 1. And of course, solving, we will get x is equal to negative 1 and x is equal to 2. Let us substitute these values in turn into equation 1. Of course, we have equation 1 right here. We have two values of x here. We will therefore get two values for y also. This value of x will yield the result that is dependent on the equation that we have right there. So let us substitute negative 1 into this equation. So we will get y is equal to, instead of x, negative 1. So y is equal to negative 1 plus 2. Negative 1 plus 2 is equal to 1. So y is equal to 1. And of course, we will put 2 into the same equation and see what happens. 2 goes right here. Y is equal to 2 plus 2. So y is equal to 4. So we are going to make note, as a matter of fact, of the value of x that yields the value of y. So we will not just put x is equal to -1 and 2 and then y is equal to 1 and 4. We will put them together, the value of x that yields the particular value of y. So we will write that as, when x is equal to -1, y is equal to 1, and when x is equal to 2, y is equal to 4. A strip of wire of length 32 centimeters is cut into 2 pieces. One piece is bent to form a square of side x centimeters. The other piece is bent to form a rectangle of length L centimeters and width 3 centimeters. The diagrams below, of course not drawn to scale, show the square and the rectangle. Of course, here we have the square and the rectangle, and we are required to solve some problems based on the diagrams that we have, and also other statements that will be made. The length of the strip of wire must be equal to the sum of the perimeters of the square and the rectangle. We are required to write an expression in terms of L and X for the length of the strip of wire. So let us do that. We are required to write expressions in terms of L and X for the length of the strip of wire. The length of the strip of the wire, of course, what do we expect? If the wire is bent to form a square and a rectangle, it means that the perimeter of the square plus the perimeter of the rectangle is equal to the length of the wire that was used to form those shapes. Right? So let us go straight ahead. 32 is the length of the wire, and of course this is a square. The perimeter of this square is going to be equal to this side plus this side, and of course these two sides are going to be the same because we have a square. All the sides of a square are equal, so we have 4 equal sides, each of x centimeters. So the perimeter of the square is going to be 4x. As we have it right there, the square is blue, and we have highlighted the perimeter of the square with blue. And of course, this part is going to be the perimeter of the rectangle. Of course, the rectangle has 2 pairs of equal sides. So we have L here and L down here also. So that will be L plus L, 2L. And of course, we have 3 on this side and also 3 on this side. So we have 6. So we have L plus 3 plus 3. And that will be the perimeter of the rectangle. And it is going to be simplified as 2L plus 6. We are required to manipulate this expression in order to arrive at the expression that is suggested in the statement of the problem. Of course, we can see right here that each term may be divided by 2. 2 into 32 is 16, 4 divided by 2 is 2, and so on. Next, we are expected to have the L on the left hand side and everything else on the right hand side. By so doing, we will make L the subject of the formula, in which we keep this L first on the right hand side, transpose everything else to the left hand side. No doubt we will have, resulting from this positive 2x that we have on the right hand side, a negative 2x right here, and of course from this positive 3 that we have on the right hand side, a negative 3 on the left hand side. So 16 minus 2x minus 3 is equal to L. However, we have 16 minus 3, but they are like terms, they are constants, real number values. So all we need to do is just take away this 3 from 16 and we will get 13. So we have 13 minus 2x on the left hand side and L on the right hand side. Finally, we will just say L is equal to 13 minus 2x. And that's all that is required. The sum of the areas of the square and rectangle is represented by S. So, the sum of the areas. What is the area of this square? Length times width. But in a square, the length and the width are equal. So we're going to have x multiplied by x, which is equal to x squared. So that is going to be the area of the square. And what about the area of the rectangle? That is going to be L times 3, which is 3L. So we have the sum of the areas will be equal to x squared plus 3L. X times x, x squared. L times 3 is equal to 3L. And of course, we highlight this in blue to show that this is the area of the square. And of course, the one highlighted in red is the area of the red rectangle. But we have seen that so far, so we need not expound on that one anymore. The statement of the problem is instructing us to find an expression for S. But as we have it right here from the previous section, L, it is this L that we have here, is equal to 13 minus 2x. So where we have L, we replace that with 13 minus 2x. So S is equal to x squared, then 3L. But L is 13 minus 2x. And of course, we may expand this bracket. 13 times 3 is 39, and 3 times 2 is 6. So we have x squared plus 39 minus 6x. And of course, we can write that in a trinomial form. And that is the result. We are required now to find the values of x for which S is equal to 30.25. So there we have our expression for S, and we are told that S is equal to 30.25. So where we see S, we put 30.25. Then we are required to solve this equation in order to find the values of x. So first thing, we are going to clear this decimal fraction that we have here by multiplying through the entire equation by 100. So we have a horribly large expression. That is it. A very large expression. But of course, we may take another step to simplify. We may divide through the entire equation by 25. But first, let us transpose the 3025 to the right hand side. By so doing, we will have 100x squared right there, 600x right there, and of course we will not bother to transpose the 3025 to the right hand side and then subtract that 3025 from 3900. We will just do that in one step. So we're going to take the 3025 to the right hand side, and we will subtract that because it is a positive on that side. So we'll subtract that from 3900. We'll do that in one step, and the result is 875. We will then proceed to divide through the entire equation by 25, and that is the result. Of course, we have somewhat large coefficients still, but I think that the numbers are very simple to be manipulated, and that I will demonstrate in a minute. We need to find the two numbers that multiply to give 4 times 35, which is, of course, we may not multiply 4 times 35 at once. We may take 2 out of this 4 and say 2 times 35 is 70. And then take the other 2 and say 2 times 70 is 140. Right. So the two numbers will multiply to give 140, and they are going to be added to give a negative 24? Well, if anybody asks me the simplest numbers to multiply to give 140, I would tell them 10 times 14. Right, the two numbers are 10 and 14, a negative 10 and a negative 14. We have 4x squared minus 10x minus 14x plus 35. And of course, we are going to factorize 2 by 2, factorization by grouping. We are in section 2 of the paper. The factorization of a trinomial should not pose too much problem here, especially that we have them in quadratic form, and we may use factorization by grouping. So that will be our result. And of course, if we are going to say 0 is equal to this multiplied by this, either this is equal to 0 or this is equal to 0. If this one is equal to 0, we transpose the 5 to the other side, so 2x is equal to 5. And then, if 2x is equal to 5, we will divide by 2. So we will have x is equal to 5 over 2. And the same thing will happen right here. X is equal to 7 over 2. So those are the values of x. And we have made light work of problem number 9. Now number 10 is a linear programming problem that says the owner of a parking lot wishes to park X vans and Y cars for persons attending a function. The lot provides parking for no more than 60 vehicles. We are required to write an inequality to represent this information. Do not forget, X is the number of vans and Y is the number of cars. And no more than 60 vehicles. So no more means what? No more than 60 vehicles mean that the total number must be less than 60 or equal to 60. Therefore, the total will be the summation or the sum of x and y. So x plus y must be less than or equal to 60. At least 10. So we have here, to get a good bargain, he must provide parking space for at least 10 cars. What does at least 10 mean? At least 10 means 10 is the least. Therefore, he must provide parking space for 10 or more. So, y is greater than or equal to 10. The number of cars parked must be fewer than or equal to twice the number of vans. Right? So we have what? The number of cars parked must be fewer than twice the number of vans. Of course, fewer just means less. The number of cars is less than or equal to twice the number of vans. So the number of cars, y, is less than or equal to twice the number of vans. We are going to start to graph the inequalities. And of course, the one that we are going to graph first is this one. But before we go to the graph, we are going to find points through which this line, x plus y is less than or equal to 60, must pass. And of course, if we take a look at volume 2, straight line graphs, and also some subsequent volumes, we will be reminded how simple it may be to graph a line, especially when the equation is written with the x and y on the right hand side and the constant number, real number 60 or any other real number on the right hand side. We will do that by equating each of x and y to 0 and find the value of the one that is not equal to 0. And we'll see how that works out in a minute. So when x is equal to 0, if we are going to say x plus y is equal to 60, that is the associated line, x plus y is equal to 60, if we are going to say x plus y is equal to 60 and we are going to say x is equal to 0, what happens? 0 plus y is equal to 60. Therefore, y is equal to 60. The line then will pass through the point which coordinates what? X part is 0 and the y part is 60. And then if y is equal to 0, the x, we have it right there, we equate the y part to 0, and that is also equal to 60. So that will cause the x to be equal to 60. So for that point, we have the x ordinate is 60 and the y ordinate is 0. The first line will pass through the point 0, 60 and 60, 0. So let us look at the graph and see how we may be able to plot those points. We are going to plot the points for the first line. 0, 60. The x ordinate is 0, the y ordinate is 60. Here we will not move along the x-axis because the x value is 0. We will move up to 60. Then we have 60, 0. We will move 60 out to x, but the y is 0. We will have no further movement, and we plot the point right there. And then, finally, we'll draw that line. Draw the associated line. Line must be passing through 0, 60 and 60, 0. Do not forget that in order to fix a straight line, we need only 2 points. The second line has equation y is equal to 10. And of course, if we consult functions part 1 of Richard James Mathematics Resources, functions 1, we have straight line graphs right there. And of course, if y is equal to a constant, that line will be parallel to the x-axis. That one will be a horizontal line that crosses or touches the y-axis at 10. So that one is a horizontal line that crosses the y-axis at 10. We may say it touches the y-axis at 10 also. Line 3 is a popular line in Richard James Mathematics Resources. Y is equal to 2x. What does that mean? It simply means that whatever x is, y is twice that. So if x is equal to 0, y is equal to 2 times 0, which is 0. And if x is equal to 30, y is equal to 2 times 30, which is 60, and so on. It is not difficult to arrive at the points that we are going to use to draw that line. So everywhere on that line, the value of y is twice the value of x. It will pass through the points like, say, x is 0, 0 times 2 is 0. X is 30, 30 times 2 is equal to 60. X is 10, 10 times 2 is equal to 20. So whatever the value of x is, y is 2 times that. So we are going to plot that point 0, 0, that is the origin, 30, 60, 30, 60, right there, and 10, 20. So we go to 10 and we go up to 20. And of course, the line will pass through those points. No problem with that. So we are going to identify the region that satisfies all of the inequalities. And of course, the region must be less than this line, because y is less than or equal to 2x. Must be below that line because y is less than or equal to 2x. And it must also be below this line because x plus y is less than or equal to 60. And it must also be the region that begins at this line and above because y is greater than or equal to 10. And of course, it is going to be this region that is bounded by all three lines. Not very difficult in this particular case to arrive at that region. There we have it. The objective function is an expression of the total fees that may be found by multiplying the cost of parking the type of vehicles by the number of them. So the objective function is an expression of the total fees. And we will get the total fees by multiplying the fee for parking vans by the number of vans, and of course multiplying the fees for parking cars by the number of cars. And of course we are going to add those. So let's see, we have the fee for parking a van is $6, so we're going to have what? 6 times X. And that for parking a car is $5, so we're going to have 5 times Y. So 6X plus 5Y. The coordinates of the vertices of the shaded region, we need to find those also. So no problem identifying them. We have that first one. That first one is 20, 40. Do not forget that writing down coordinates, we use the X values first. We still have students writing Y values first. The other one, right there, we have 50, 10. And finally, we have 5, 10. If we are going to determine the maximum amount to be made, or the maximum amount of fees charged, this ordinate, this pair of coordinates will be out of the question. There's no way this can give the maximum. Usually the one that you can find that has both ordinates less than the 2 ordinates of any other point, that one is normally out. And I think that if we compare it with this one, the 5 is less than the 50 and the 10s are equal. The 10s being equal will not cause it to be more, because in this particular case the 50 is greater than the 5, so we know that this one is automatically out. And if we compare it with this one, we realize that the 5 is less than the 20 and the 10 is less than the 40, so there is no way this one can give the maximum amount of fees. So the larger coefficient in the objective function is the coefficient of x, which is 6. So the large coefficient in the objective function is this one. The vertex that will give the maximum profit is the one with the largest x value. Usually that is the case. If there is a violation of that rule, then we will resort to the other pair of coordinates. But in this particular case, if we use this large value in the pair of coordinates, it will be matched with this one. As a matter of fact, 50 is an x ordinate, so the 6 is going to be multiplied by x. Therefore 6 is going to be multiplied by 50. So this large number will be multiplied by 6. Therefore it is quite likely that this is going to give them the maximum profit. Of course it does. I've done a rough check with this one and that one, and in this particular case our rule is not violated. So in this particular case our rule is not violated. The maximum fee is 6 times 50, 300, plus 5 times 10, 50. So it's 300 plus 50, and that is 350. The diagram that we have right there shows a vertical tower TF, and on top of that tower we have an antenna TW. We are going to insert the distance 28 meters. PF is equal to 28 meters. So let us put that right there. 28 meters. And of course, we are going to insert also the angles 40 degrees and 50 degrees. The angle of elevation from P to T is 40 degrees. And the angle of elevation from P to W is 54 degrees. So let us put those in. The 54 degrees goes first. The angle of elevation, as we can see, the angle is going all the way here. So it is the angle of elevation of the top of the antenna from P, and that is 54 degrees. And the one up to the top of the tower is 40 degrees. Is there any right angle? Of course, we know that a horizontal and a vertical, so this is the horizontal ground, and a vertical tower will meet at right angles. So we will have a right angle right there. No problem. And then now we are required to calculate the value of TW. So let us calculate TW. The height of the antenna that we have, which is TW, is the difference between the height of the building and the antenna together and the height of the building. So let us put this in a way that is more easily understood. If we want to find the height of the antenna alone, we may find the height of the total height, of course, of the antenna and the building. Then we will subtract the height of the building, which is the tower. We will subtract the height of the tower from the total height of the tower and the antenna together. So when we do that, we will find the height TW. And notice, of course, that we have this adjacent distance 28 meters, and in this right angle triangle, in both right angle triangles, the heights that we are interested in are opposite to the angles. So we have opposite and adjacent, so we are talking about tan. So we have FW. What is FW? FW is the total height of the building and the tower together. And FW over 28, which is opposite over adjacent, and that is equal to tan 54. So FW is equal to 28 tan 54. And in this particular problem, we do not need to know the height of the tower and the antenna together. So we need not simplify that immediately. So now we will find TF, which is what? TF is the height of the tower alone. And of course, it is analogous to the one that we have just found. So we need not go through the entire process. So we know that FT or TF, FT is equal to 28 tan 40. That is what it's going to turn out to be, because the two calculations are analogous to each other. So if we subtract one from the other, we will find the height of the antenna. So TW is equal to 28 tan 54 minus 28 tan 40. And when we do that calculation, we get TW is equal to 15 meters. And of course, that is very straightforward. We wish that every problem in CSEC trigonometry would be like this one. But we are going to be disappointed if our hopes are too high. In this particular case, as we see this problem, we know what is going to be required. State, given reason, or calculate, given reasons, the value of certain angles. And of course, the first one that we are going to state is OCE. O, C, E. So the angle is at C. We want to know what that angle is. As a matter of fact, I've stated it to be 90 degrees already. Now I'm going to state the reason. Notice what we have. We have this tangent right here. We have this tangent right here. And of course, OC is the radius of the circle. And we know that what? Radius and tangent meet at right angles. Radius and tangent meets at right angles. So OCE is 90 degrees. OCE. The other one, BAC is equal to 70 degrees. BAC is 70 degrees. And what is the reason for that? We have two angles, this one, which is of course the angle that the chord makes with the tangent. So we have the angle that the chord makes with the tangent. The angle that the chord makes with the tangent is equal to the angle that is subtended by the chord at the circumference. Say the angle subtended by the chord at the circumference is equal to the angle that the chord makes with the tangent. And that is why BAC is equal to 70 degrees. There we have it. The angle subtended by the chord at the circumference. So this is the chord. And this is the angle that it subtends at the circumference. It is equal to the angle that the chord makes with the tangent. And that is always the case. Any more? Well, I guess BOC is equal to 140 degrees. BOC. BOC 140 degrees. Is there a reason for that? Yes. If two angles are subtended by the same arc, the one at the center is twice the one at the circumference. So the one at the center, this one, of course, they are subtended. If you want to say the same arc or the same chord, it's going to be the same thing. So the one is subtended by the same arc. We have this arc right here, and the angle subtending the arc is this one at the circumference, and this one at the center. This one at the center. Therefore, the angle that is subtended at the center is twice the one at the circumference. No problem with that one. BDC is 40 degrees. BDC is 40 degrees. How so? If two tangents are drawn to the same circle, they are equal in length. If they are drawn from the same point. So we have two tangents to the same circle. They are drawn from this point. Therefore, at the point of tangency, we have from D to B is equal to from D to C. So we have an isosceles triangle. So if this angle is 70 degrees, so is this one. So the one that we have down here is the rest of 180 degrees. So 70 plus 70, and we are going to subtract that from 180. Or we may say 180 minus 2 times 70. So we have 180 minus 2 times 70, and that is equal to 40 degrees. There we have a parallelogram. And of course, information about the parallelogram is already given. We are required to find the length of the diagonal HF. And of course, we are going to single out a triangle by which we will do that. By considering the triangle EFH, we notice that FH is opposite to the known angle, and the two sides that form the angle are also known. We may therefore apply the cosine rule. Now, if we are going to find HF, we are going to apply the cosine rule to any situation that we are required to find the side that is opposite to a known angle. If the two sides that form the angle are already known, we need to find the side opposite to the angle, and the two sides that form the angle are already known, so we are going to go straight ahead and apply the cosine rule. So, of course, HF squared is equal to 4.2 squared plus 6 squared minus 2 times 4.2 times 6 cosine 70. And that is what we have right there. When we simplify, we get, of course, squaring 6, we get 36. And of course, if we square this, this will be the result. And we'll go straight ahead, multiplying 2 times 6 times 4.2 times cosine of 70, and we'll get 17.24. Then, of course, we will just do the simple arithmetic, and we get HF squared is equal to 36.4. Then, of course, we need to find the square root of 36.4. So HF is equal to 6.03 centimeters. And let's see if there's anything else we need to find. Of course, we need to find the area of the parallelogram EFGH. So find the area of the parallelogram EFGH. The area is equal to 4.2 times 6 times sine of 70. The area of the triangle EFH may be found by taking half of the product of any two of its sides and multiplying the result by the sine of the angle that the two sides form. So to find the area of any triangle, find half of the product of any two sides, multiply that result by the sine of the angle that the two sides form, and that will give you the area of the triangle. But notice that we have two triangles of equal size, so the area of the entire parallelogram will be 2 times a half times the product of the two sides multiplied by sine of the angle that the two sides form. So we take 2 times half. 2 times half is equal to 1. A coefficient of 1 is not necessary to be written because 1 multiplied by anything is that same thing. So that is why we have the area is equal to, instead of a half times the product of the two sides times sine of the angle, we use what? The product of the two sides times sine of the angle. If we take half, as is customary when we are finding the area of a triangle, we are going to multiply that half by 2 because we have 2 of those triangles, and that is why the half is eliminated in this particular case. Our favorite. I'm taking this brave step to include the solution of problems on earth geometry, although earth geometry by this time is out of the syllabus. I have no doubt that the CSEC CSEC will reconsider in a short while to include earth geometry. It is simpler to me than bearings, for one, because if you know that we are required to do basically only 3 things. Also, the globalization and the consequences and the implications, I think implications is a more appropriate word than consequences, dictate that we all know how to make calculations and to also manipulate situations in which the earth is described to be a sphere and we are required to make calculations. So I'm continuing with it, knowing that in the long run it is going to return to the CSEC syllabus. So I am making sure that when it does, the Jamaican people and the people of the region, and probably by extension the people in the world, will have solutions to problems involving the earth as a sphere. Now in this one, we are required to include the Greenwich meridian and the equator. Of course, we have two lines of longitude. One is 4 degrees east. This one is east, of course, if the Greenwich meridian is inside here. So this one is going to be 4 degrees east, and the next one is going to be 74 degrees west. But let us put the equator in first. That's our equator. And of course, what's next? The Greenwich meridian. Right there. No problem. We have 2 points that we like to include also. 41 degrees north, 74 degrees west. Of course, this line is the 74 degrees west, so we expect Y to be right there. And M, 41 degrees north and 4 degrees east. So we expect that one to be right there. Of course, this line is 4 degrees east. We are next required to find the circumference of the circle 41 degrees north. And this one is always a very simple problem. We know that the radius of that circle is the radius of the earth times cosine of the angle. And we know that the circumference of any circle is what? 2 times pi times r, 2 pi r. So we have 2 times pi times r, but the radius that we have is the radius of the earth times cosine of theta, because we are talking about the radius of the circle of latitude 41 degrees north. So this angle is going to be 41 degrees. So we have what? 2 times 3.14. It was suggested that we use 3.14 in the problem, in the statement of the problem. And we have the radius of the earth right here, and we multiply that by cosine of 41. We could have found the radius of the circle, then use it to find the circumference. But we need not do that if we can do it in one step. And that is the result after doing all of this arithmetic. 30,191 kilometers. This is the formula that we use to find the circumference of the circle. We know that that formula is 2 pi r. The radius of any circle of latitude is the radius of the earth multiplied by cosine of the associated angle of latitude. And so we are just substituting the radius for the radius of the earth cos theta, which is 6,370 times cosine of 41, and that is what the radius of the circle of latitude will be. And of course, we multiply that by 2 pi, and presto, the answer is right there. Well, it's not so simple. We'll have to put the instruction in a calculator, especially for the cosine of 41. We may use the regular formula for calculating the length of an arc, because that is what is required. We are required in this case to calculate the shortest distance between y and m measured along the circle of latitude 41. So this is the circle of latitude 41 degrees north, and we need to find the distance between y and m. Of course, this distance is going to be the length of an arc. So we need to know the associated angle for that arc. This y is 74 degrees in this direction, and this m is 4 degrees in the other direction. So in all, if we go all the way across here, we will have a 74 and a 4. So that will be 78 degrees. And of course, we know that the arc is a fraction of the circumference of the circle, and the fraction is determined by the angle associated with the arc divided by the angle of an entire revolution, which is 360 degrees, and that we multiply by the circumference of the circle. And the circumference of the circle, we have it right here already. So we are going to just say what? 78 over 360 multiplied by that, and the result is 6,541 kilometers. We need to show the point B such that OABC is a parallelogram. So the first thing that we are going to do is insert that point B in such a way that OABC is a parallelogram. If it is a parallelogram, that means the distance that we have from A to B is the same distance as from O to C. So let us see how we'll arrive at that. C is vertically above O, as we have it right here. Right. So if that is the case, we will place B above A. Let's see by how many? 1, 2, 3, 4 units. So we'll put it 1, 2, 3, 4 units right there. So that is where B is going to be. B is going to be. I like that. OA, let's see what the vector OA is. We go from O to A by 6 units in the x direction, and how many units? 1, 2 in the y direction. So OA is 6, 2. What else? U is equal to OA plus OC. Well, that is something that we can do by manipulating the vectors in an arithmetic way. We can do it graphically. Well, since we have the graph, let us just do it graphically. We have OA is that one, no doubt about it, we are just highlighting it. And then OC is that one, no doubt about it either. What we are going to do, we are going to add OA and OC. So we are going to go from O to A, and then we add the vector OC. Now the vector OC may well be placed at the end of the vector A. So we do OA and then take the same vector that is equal to OC. We move according to the movement of that vector. So we are taking the vector OC and we are putting it at the end of A. Right? So we are going to add OC to OA, and the result is the vector U. So if we add this one with this one, the entire movement is going to be the vector U. So the vector U will be that one. So that is U. We are expected to write down, not calculate the vectors. It is appropriate to use a graph and step through the movement. So which one are we going to be writing down now? OA. Right, so OA is what? 6 movements, so 6 units in the positive x direction and 2 units in the positive y direction. So OA is 6, 2. Any other? Of course. OC has only a vertical movement by 4 units. The movement in the x direction is equal to 0. So vertical movement alone, no horizontal movement. We are sure that the movement associated with C is 0 in the x direction and 4 in the y direction. No problem with that either. And if there is any other one, it is AC, and what do? We move from A to C. So we're moving in this direction now from A. So from A we go like this, in the negative x direction. So we go 1, 2, 3, 4, 5, 6 units, and then positive 2 in the y direction. So AC is negative 6 followed by positive 2 in the y direction. Negative 6, 2, that's a vector AC. Given that G is the midpoint of OB, use a vector method to determine the coordinates of G. So G is the midpoint of OB. So that is OB. So OB is 6 in this direction, 6 in that direction. So 6 in the positive X, 6 in the positive Y. OB is 6, 6. But it is said that G is the midpoint of OB. So OG is a half of OB. So OG is a half of 6, 6, which is equal to 3, 3. Or we could have done that graphically to see where halfway along this line would have been. And it would not have been difficult. Neither is it difficult with this method that we are using right here. So OG is a half of 6, 6, which is a vector that is equal to 3, 3. Now, the question did not say find the vector G. It says find the coordinates of G. So we need to write that in coordinate form. So G is the point 3, 3. And, of course, prove using a vector method that A, G, and C lie on a straight line. And if they lie on a straight line, we always say that they are collinear. So AG is OG minus OA. That is the triangular law. AG is OG minus OA. And that is what we have. And that is equal to negative 3, 1. So AG is negative 3, 1. Let us read the problem again and give the students an idea of what we are trying to achieve by doing this. Prove using a vector method that A, G, and C are on a straight line. On a straight line means collinear. If 3 points are collinear, then we need to find 2 vectors involving the 3 points. The 2 vectors that involve the 3 points will be parallel if the points are collinear. Now, if we are talking about A, G, and C, we need to calculate the vector AG or some other vector. But of course, the statement of the problem requires that we find AC already. So we know AC, so we need only one other vector. This time we are choosing AG. So we find AG to be negative 3, 1. Of course, AC is negative 6, 2. And AG is negative 3, 1. There we have our 2 vectors that involve the 3 points. We have A repeated, that's not a problem, as long as we have C and G also. So we have the 2 vectors that involve the 3 points, and we are going to show that the points are collinear. They are on the same straight line. So if 3 points are collinear, then the 2 vectors that involve the 3 of them are parallel. It is plain that one vector is exactly twice the other. This means that they are parallel. The points A, C, and G are therefore collinear. So these vectors are parallel because one is exactly twice the other. If we can take one vector and multiply it by just a pure number and arrive at another vector, then we know that those 2 vectors are parallel. So AC is equal to 2 times negative 3, 1. This is AC. If we take 2, like factorization, take 2 outside, it's going to be 2 into negative 6, negative 3, and 2 into 2 is 1. So notice that we have 2 times negative 3, 1. But negative 3, 1 that we have right here is the vector AG. So AC is equal to 2AG, and we are sure that the 2 vectors are parallel. Therefore, the points A, C, and G have been proven to be collinear. Finally, we have this matrix M is equal to 2, 3, negative 1x. So we are going to calculate the value of x if the determinant is equal to 9. 2 times x minus negative 1 times 3, and that is equal to 9. So we have 2x minus negative 1 times 3. So we're going to have what? Negative 1 Here we have negative, negative again. So we are going to have a positive 3 when we put all of this together. So we have 2x plus 3 is equal to 9. So by transposition and of course solving this simple linear equation, 3 is taken to the other side, positive 3 here, we subtract 3 from this side also, so we have 2x is equal to 6. And of course x is equal to 6 divided by 2, which is equal to 3. That's very interesting. Next, we are required to use this value of x in finding M inverse, the inverse of the matrix that we have right here if x is replaced with 3. So what do we have? The inverse will be equal to 1 over the determinant multiplied by the adjoint. Now of course we do not have to go through some sophisticated calculation in order to determine the determinant, because we have x is equal to 3 here, and of course the determinant we have it right there. So we put x to be 3 here, so we have 2 times 3 is 6 plus 3 is 9, so the determinant is 9. So we have M inverse is equal to 1 over the determinant that is equal to 9, and we are going to have the adjoint. Of course the adjoint is going to be required that we have this 3 that we would normally have right here. We are going to exchange the places of these two. So then this 3 will go there and the 2 will go down here. So the 3 will go there and 2 right here. We will change the sign of these two. So this being a positive will be changed to negative 3, and this being a negative 1 will be changed to positive 1. And we are going to divide each one of these terms by 9. Of course, by dividing by 9 right here, we may reduce the fraction by a common factor of 3, and the same thing applies right here. And this is our result. These do not have any common factor with 9, so we just put 1 over 9 and 2 over 9. Next, we need to multiply M inverse by M. Of course, we may use this matrix to multiply, which is M inverse, to multiply the matrix M. But it is not necessary for us to do that. We may write the inverse in the original form and use it in our multiplication process in such a way that we do not have to encounter those cumbersome fractions. And then we see what will happen at the end. So we take this 1/9 to be multiplied by these, and of course the resulting matrix is given right there. So we take the first row multiplied by the first column. So 3 2's multiplied by negative 3, negative 1. That is what we have there. And of course the first row multiplied by the second column. 3 3 multiplied 3 multiplied by 3 plus negative 3 3. And of course right here we have the lower row by the left. So the answer will go to the lower left. The lower by the left we have what? 1 2 plus 2 negative 1. And finally the lower multiplied by the right we have what? 1 3 plus 2 3. Right. And when we put all that together we will get 6 plus negative times negative is positive. We have 6 plus 3, that is 9. 9 minus 9 is 0. 2 minus 2 is 0. 3 plus 6 is equal to 9. So we have 9009. And of course we have a 1/9 right there. So we may now take this 1/9 into this matrix, and we will get what? 9 divided by 9 is 1, 0 divided by 9 is 0, and so on. So that is our result. In the solution of this problem, students will be required to consult the diagram on the paper. And of course we are working with the May 2006 paper. And of course this requires that we put in the form of a 2 by 2 matrix the coordinates of the point A and the coordinates of the point C. So we're going to put them in a vertical form. A has coordinates 2, 4. We put that vertically, 2, 4. And C has coordinates 5, 3. And we write that vertically also. We also need to write the coordinates of the images of A and C in a 2 by 2 matrix in the same way. Of course, A prime has coordinates 2, negative 4, and C prime has coordinates 5, negative 3. We are going to be using matrices only to write an equation to represent the transformation AC onto A prime, B prime. Of course, the matrix that is responsible for that transformation we'll see in a minute. The matrix that is responsible is P, Q, R, S. Now P, Q, R, S is multiplied by each point to be transformed, and the result is the images of the 2 points. So we have A will be 2, 4, and A prime will be 2, negative 4. C is 5, 3, and C prime will be 5, negative 3. And of course, this multiplied by this is equal to this one. And we are required to find the values of P, Q, R, and S. Now, what do we know? This is a matrix equation. We cannot divide by matrices. If we were doing like a simple linear equation, what would we do? We would divide by this. That's what we would have done. We would divide by this. But we cannot divide in the matrix world. So we will what? Multiply by the inverse. So we will multiply by the inverse of this. Now, we are going to be eliminating. Notice how the matrices are written. The known is on the right and the unknown is on the left. Therefore, we are going to take the inverse of this one to multiply it right here. And of course, we are going to do the same on the other side. I think that there is a great reason why the examiners gave this problem. And I'm going to explain that in a minute. So what do we do? Notice that these are the same as these. And what is this? This is the inverse of this one that we are multiplying on this side. So to find the inverse, we do what? Exchange these two and change the sign of these two. And of course that needs to be multiplied by 1 over the determinant. So the determinant is 2 3s minus 5 4. That's what we have right there. Now this, all of this constitutes the inverse of this matrix, which is of course this same matrix. So we have the equation written with the left hand side right here, and it is the same thing here, but we are multiplying by the inverse of this matrix right there. What do we do on this side? What we do to one side, we do that to the other side. We multiply by the inverse of this same matrix, which is this same inverse on the other side. But we would have received the wrong answer, or at least we would have taken the wrong approach if we took this inverse here and put it on the, or before, let us say in front of. So we put this inverse, notice the inverse is placed behind, on the, behind this product on the left hand side. It is therefore to be placed behind this matrix on the right hand side. And that is what we have done. Of course, we have simplified the determinant right here. But why did we do that? Why we couldn't have put it behind the product on the left hand side and then put it in front of the product on the right hand side? Because the result will not necessarily be the correct result. And that is because multiplication of matrices is not commutative. So the order in which we multiply matrices does affect the result. Therefore, we are to be sure that if the inverse is placed to the back on the left hand side, it is to be placed to the back on the right hand side. So multiplying, of course, we will not multiply the negative 1/14 inside first. We will do that when we have completed the matrix multiplication. And of course, the result turns out to be this. So we are going to take this 1/14, negative 1/14 inside and see what we have for our result. And of course, the result is P is equal to 1, Q is equal to 0, R is equal to 0, and S is equal to negative 1.